Plymouth is one of the pilot cities in the D2Grids project. We've been developing heat networks in the city for a number of years. This particular project is around fifth generation principles, which means it's providing heating and cooling between buildings by sharing renewable or waste heat sources from a variety of locations, which may include things like waste heat from cooling, the sea water, geothermal, or from the air. The approach we're taking in Plymouth is very unusual and quite unique in the UK, in the sense that most district energy schemes or heat network schemes operate on higher temperatures with pre-insulated pipes. This is a very low temperature system that uses heat pumps at the building level to step up the temperature to provide heating and cooling. It's a good way of adapting to climate change by being able to future-proof developments in terms of cooling demand as well as heating. Because obviously heat pumps require electricity to run, we've been installing solar panels to supply renewable electricity at some time of the year to run those heat pumps.
Plymouth is a city that's surrounded on both sides by open sea. What makes the project unique is that a couple of years ago a water well was drilled at the site of the Plymouth pavilions, and that water well has proven to be very, very productive. It produces a lot of water with the potential to heat the equivalent of hundreds of homes. Our boreholes that are located within the city, they're actually pumping seawater through a rock filter. So the seawater is being cleansed, it's being cleaned, and that means that we can use that seawater for heating and cooling, and then we can simply return that water back to the sea, which makes it a much safer and a much more economic proposition than 90% of applications of this technology worldwide. It'll be a very elegant heating and cooling solution. It'll provide cheap, low-carbon heat to homes and businesses across the city, and the only waste product is cool seawater going back to the sea. And in an overheating planet, a cool discharge is a good thing.
We've been on site for the past week doing a constant rate test to understand the sustainable level of flow we can pump water out of the ground. And we've managed to get it sustainably up to about 70 litres a second, which means it should be one of the most sustainable and responsive geothermal wells in the UK.
The benefits of moving to a water-based solution from a fifth generation network is that we get improved efficiency at the time that you most need it, in the depths of winter. Actually, the water that we can take from the ground, which is ultimately in this case going to be coming from the sea, is about 12 to 13 degrees, which is much more efficient when we're using that to generate heat at the time of need. This particular building is fifth generation ready, which means that in its current guise we'll be operating as an air source heat pump, but the heat pump, the compressor below, is actually ready to accept a water connection. This is just designed to serve the building itself, but it is future-proof to be connected into a bigger network. Specifically here in Mill Bay, we're looking at a fifth generation cluster, but actually what we're looking at over Plymouth is a bigger master plan of networks that will interconnect to deliver low carbon heat across the city. So this is one part of a cluster. We've also got another cluster forming around the Guildhall and the Civic Centre, and that will deliver low carbon heat there and will be designed in such a way that can be interconnected in the future with this network.
We're excited about this scheme in terms of Plymouth because it could be rolled out in other parts of the city centre, in particular where there are heating and cooling demands. But we're also excited by the learning from this project because of its relevance to other towns and cities in the UK.